semester assignment and tests falls basically around the same week. So I'm trying to catch up time to finish all up. But last week was quite a busy week because of the MQVA. They came and visited, not visited like physically, but virtually. So there was a lot of time spent on the course files, preparing for the visit. There was an interview some more. So that took quite a lot of my time, of which I had to commute to the campus and be there, and I have less time. But basically, that's my excuse. It's I should be able to do it, but unfortunately, I haven't finished. Therefore, I'm not able to return you the paper today. But hopefully, if I can get some time today, I will finish the marking and return your test paper by tomorrow. If not, then it will have to be next week. So I try to find some time today, but my class today is the whole day. So see how it goes. Yeah. Um, it's week 10 and we are on chapter 6. You only have this chapter and one more chapter, and then we'll be finished with this subject, probability and statistics. And yeah, anything you guys would like to raise up before I start the lecture for today? Because my plan is to finish all these slides today, as what has been shown to you all. There are about 36 slides altogether. We have covered up to 9 slides, so we have about 26 slides to cover today. I hope we can finish it up. If not, we can continue it to next class, which is tomorrow, because tomorrow is tutorial and the last few slides are basically just examples for you to be familiarized with the way the question is being asked. Any question, anybody?
No.
No question, is it?
No.
Okay. If no question, then I should be starting the session then. Let me just check, yeah. Can you hear me clearly?
Oh, yeah.
All is okay, huh? So let me start with the recording and then we'll start the class. Good morning. Today is the 24th. No, today is the 22nd of March and 2021. It's week 10 for the semester 202101. It's the third semester of the academic year 2020-2021. Yeah, and we are very soon now, about 4 weeks' time after this week, we will finish the semester and you'll be going to your second year for your degree program by then, by next semester. Yeah. So this week, my plan is on this week 10, my plan is to finish the hypothesis testing, which we have started last week. And hopefully this week, without any problem, we should be able to cover the whole chapter. And yeah, make sure that all of you understand this topic. Yeah. I do have received feedback that, I mean, not from concerning you guys, but from other batches, that they do find it's a bit difficult to adjust to this subject because this subject is about statistics, and normally this subject is conducted in face-to-face mode, but unfortunately, because of the pandemic, we have to do it online. I hope throughout the semester you guys can cope with this topics coverage. I do understand it needs some adjustment to how you learn this topic, but I hope you can understand the topic contents, and if you have any problems to understand any parts of the topic, let me know. Yeah. Of course, I hope you all realize that when you're doing subjects concerning mathematical calculation, in fact, same thing like programming subjects, you need to keep on, practice. Yeah, try out until you get the full concept of it and be able to answer whatever format the question is. And talking about format, uh, I hope you guys also understand that the format of the question is basically the same, yeah, all throughout the exam. I mean, if it's in one topic, the way the question is being asked is the same manner. It doesn't, drastically change from one type of question to another concerning one particular topic. So, even though it is conducted online, I hope you guys can understand what I share, and it's all up to you to make the effort to do the practice. Yeah, this I have to say because sometimes we tend to forget, myself included, tend to forget that practice is important. Yeah, so like myself, if I forget to do practice, I tend to forget the topic. How is it done? So I have to refresh myself back to remember what or how to solve a certain particular type of question. Okay, yeah, so what I'm trying to say is basically during the lectures, which is only few more topics for this course, um, I hope if you do not understand any parts to let me know, yeah. But the most important thing is to have the passion to solve it, to have the motivation. That's the most important thing. And yeah, determination basically to not give up and try your best to solve whatever question considering probability and statistics. But I guess you all know, yeah, like wherever you go in higher education now, almost all are doing online learning at the moment, of which I see our country is going to change pretty soon back to normal, hopefully, because the vaccine has been out and people started to get it. Yeah, so hopefully we can go back to the campus and face to face. But unfortunately for our subject, it is a bit too late for that. Because I was informed the recent meeting that we do go back in the month of May, but that is basically during the semester break. So the new semester next which is somewhere in June, um, I have a feeling we should be back, yeah, in the campus. So without talking so much about nothing relating to probability and statistics, let me start on this topic. I mean, continue this topic. So, what I've explained to you guys last week was about the steps to perform a hypothesis testing. And these are the steps that we have, yeah, 6 steps. But I think I've mentioned when you write the answers, you don't have to write, okay, step one, and then you do this, what is stated here, what are the steps and all that. Step two, step three, and so forth. No need to write all these steps. Yeah, it will be like simply you write the answers accordingly. And the reason why I have all these steps is to ensure that when you write your answers or the solution to the question, you would follow according to this sequence as well, so that the marking process would be smoother. which I don't have to go and look at where you have written your alpha, where you have written the critical value, or where you put the test statistics, where you put the conclusion. When you write it according to these steps, then I could mark it in easier for me to find the answers that you have provided. Okay. So this slide I have explained in the last class. So now we go on to the hypothesis testing about a population mean for large sample. Now remember, I hope you do remember that when we do hypothesis testing, there are only two types we're going to learn. One is the population mean, which we're going to do now. You can see it's population mean. The other one is population proportion. Yeah, that I will touch upon that later. But first, focus on population mean. What does it mean? Based on what I've explained about null and alternative hypothesis, the H0 and H1, what you need to do, first thing first, when you get the question, yeah, is to identify what is the null hypothesis and what is the alternative hypothesis of that question. Now, how do you determine whether it's number one, number two, or number three? Is that basically you check, especially on the hypothesis, on the alternative hypothesis, H1, if it shows any kind of inequality, any difference, changes, then you would do the test of two-tailed tests. Yeah, I've explained about two-tailed, right? Of which the alpha needs to be divided by 2. So if your question asks about any difference, uh, any changes, yeah, then we would do a two-tailed test. But if the question indicates less, lower, decrease, words that signify less than, then we do a left tail test, one tail. Yeah. And if the question opposite, meaning opposite to the number 2 here, meaning like greater than, more than, increase, then we do a right tail test. Yeah. So because your step 1, let me go back to the previous slide. You see here, step 1 is to state the null and alternative hypothesis. This is the most important part. That means you must successfully state what are your null hypothesis and alternative hypothesis, and where do you get the decision to what type of test you choose is from the question. Like I said, if it shows any changes, differences, you use a two-tailed test. Any less than, decrease, left tail test. And any increase more than, we use a right tail test. Is that clear? Any question?
Stefano.
So far, no.
Okay, good. Right. So when we do the test statistics, this is the formula that you have to use. And it's not, look at it, class, it's not that different from what we have been using all this while. Maybe slightly different. In such, now you see the sample mean, which is x bar, minus the mu 0 and divide by sigma, divide again by square root n. That means the number of sample, you need to square root it. Now, all this formula, we are only to use it. We don't have to prove it. Unless you're doing a course in mathematics course, you'd have to prove it, of which I did. I did go through that, proving all this formula back then. But now, in terms of your syllabus, because this is only a course, a part of your course, you don't have to prove it. We're only going to use it. So this is the test statistics, the formula basically, of which we use in order to help us to make a decision later on. Yeah. So you need to calculate this, of which all the information you don't have to even find it. It's available in the question. I mean, you don't have to calculate all these values. It's available in the question. But there are only two things you have to consider. If the sigma is known, then you use this formula. Or if the sigma is unknown and the n is greater than or equal to 30. So just like in confidence interval, the question will not tell us, okay, sigma is known or sigma is unknown. Some question, they won't state this statement. So the best indicator would be simply this. Yeah, if your n is greater than or equal to 30, then immediately use s rather than the sigma. It's just a matter of using the correct notation. But if you look at the two formulas that you see here, number 1 and number 2, they are basically the same formula. It's just a matter of notation, because sigma is also the value of the standard deviation. The S here is also the value of the standard deviation, but concerning with the sample, whereas here it's concerning with the population. So my advice is not to be too concerned about the statement sigma is known or sigma is not known. Is focus on the n. If it's more than or equal to 30, then immediately use this formula. I hope that is clear. Yes?
Okay.
Okay. Okay, so therefore, once you have made that decision, yeah, depending on number 1, whereby we use the two tail, or number 2, one tail, which is on the left, or number 3, another one tail, which is on the right. Therefore, we decide, yeah, what is the critical value. Now, if it's a two tail, because it's a two tail, the alpha needs to be divided by 2, as you can see here. And we have two basically scenario in such that first, the rejection area would be somewhere less than the alpha divided by 2. And of course, it will be on the negative side, or it could be on the positive side, which is as you can see here, it's a greater than the value. Let me check if I did. Yeah, I did draw it here. You can see this is a two-tailed test. You can see the alpha is divided by 2. So this is basically the rejection region. So going back to the previous slide, we have the left tail. Yeah, this is the left tail. So you can see it's negative. Immediately, if it's the left tail, it would be a negative because it's on the left side of the normal distribution. It's definitely going to show us a negative area, or it could be a right tail, which of course it will be a positive value. Yeah, and diagrammatically you can see it here, or two tail, which I've mentioned just now, and one tail, which is a left tail and a right tail. See the difference? If two tail, it's divided into 2, the alpha, but one tail, the alpha, we do not divide by 2. If it's a left tail, it will be on the left side of the normal distribution, and if it's a right tail, it will be on the right side of the distribution. And basically here you can see that area is indicated as the rejection region, and inside here for the two-tailed would be the acceptance region. That means we do not reject the null hypothesis. The focus is the null hypothesis, okay? If one tail, yeah, that is the acceptance region, and basically that area is the rejection region. That means everything here. So if your value, yeah, it falls on this area, then we reject the null hypothesis. If it falls on this area, we do not reject the null hypothesis. Is that clear, class?
Oh,
Okay, all right. Now from here, let's look at an example. So basically, class, all the things that I've explained, let me just go back to the slides. Starting from the beginning, from the null hypothesis. I explained to you about what is null hypothesis. I hope you guys did make an effort to read about it before class today, understand what is null hypothesis and alternative hypothesis. If not, please make the effort to watch the recorded video again. Now, result of hypothesis testing and two types of error. These are the time when we look at the types of error. Significance level, yeah. Normally the value of the alpha would be less than 10%. Critical region, of which I started to mention about two tail and one tail, yeah. And the critical value, the steps that is required, and this is what we have discussed just now, inclusive of the test statistics. Yeah, so I hope that is all clear, and I hope it will help you to understand how it is solved. Yeah, so we're going to look at the first question. Yeah, the first question is it's about a company. They are selling car tires, and it's normally distributed, given to you the mean as 40,000, and the standard deviation is equal to 3,000 kilometer. Now you see here, a change in the production process is believed to result in a better product. Now you might say, it's a bit contradicting, isn't it? Because here we have a change, and you know, if you remember, I mentioned when there is a change, any difference, it would be a two tail. But here, it also states a better product. Better means telling us something about increase, more than. So it would be a one tail, a positive one tail. So in this case, class, you should focus on the last question, meaning the last sentence. You can see here, can you conclude that the new product is significantly better than the current one? So looking at this sentence, significantly better than the current one, it tells us that we're looking at something concerning with an increment. So definitely this is a one tail, because it shows, or the question is asking something better than the current one. So this tells us it is a one tail, and it is on the right side. Do you understand, class? Yes?
Yes.
Okay, good. So do ask if you don't understand. So that is how you can identify from the question what it is asking for. Now the alpha is 0.05. Yeah. Another information is our sample. You can see here n is equal to 64, and the mean life is 41,200. See the difference? The mean life is 41,200 from the sample, and this is our value of the mean normally distributed, which is 40,000 kilometer. So what you do first is to list out all the given information. This is our mean, mu 0, which is 40,000, our sigma, which is 3,000, our n is 64. Now, I know I did mention to you guys, if your n is bigger than 30, we're supposed to use S, isn't it? Yeah, but yeah, we're supposed to use S. But never mind, doesn't really change the answer. By right, you should use S, okay? And our sample mean is 41,200. So our random variable, always make sure you write what is the random variable so that you know what the question is about. So this is about the mean is equivalent to the true mean life of the new tires. Yeah, so that is what we want to check out, or to determine the claim, is it true or not? Is it really showing significantly a better kind of product? Yeah, so here we state the null hypothesis. The mean is equal to 40,000, which was normally distributed as 40,000, and therefore the alternative hypothesis is the mean is greater than 40,000, of which we are basically stating the claim the mean life of the new tires is better than the old tires. So that is our alternative hypothesis. Do you understand, class, how we derive that?
Okay.
Yeah. Okay. So once you have done that, okay, we have settled with the hypothesis. That's why this kind of question, this topic, is really testing on your understanding of the question. It's more like a higher order thinking skill kind of question, because you have to decide on your own what kind of test you're supposed to use. I mean, is it one tail or is it two tail? So by now, once you already determine it is greater than, we know it is a one tail, and the alpha given to us at 0.05, the critical value Z alpha is equal to Z 0.05, and you need to check from the short table, check out at 0.05. I hope you can see it is 1.6449. And of course, because this is a one tail and it's better, meaning it's a right tail, that's why we don't put negative to the Z. Yeah, no negative. It's basically a positive value. And if we draw it, because it's a one tail fan, when you draw it, you would have a normal distribution. And basically it will be here. This would be our rejection area. And the value 1.6449 would be here. Yeah, at this point, it will be 1.669. And the shaded area that I've drawn is the area that we reject the null hypothesis. Whereas the rest of the area, it will be an acceptance area. Yeah, so once you have determined 1.6449, that's the position, just a sketch lah, basically, an assumption. And therefore, we have to make our decision. Our decision is therefore, we will reject the null hypothesis if our Z, the value of the Z, the test statistics that we're going to calculate, is more than 1.6449. That means any of the area in the rejected region, the one that is shaded here now, we will reject the null hypothesis. Otherwise, we do not reject. Now, it's important to write this statement, class, because this is sort of like your decision. Yeah. So when we do the test statistics, as you can see, this is the formula. And when you put all the values in, and when you calculate it, you get 3.2. And that 3.2, class, if you draw it on the normal distribution, is somewhere here. Do you see that? It's on the green area. It's on the rejected area. 3.5 is bigger than 1.6449, right? So it will be on that particular area, on that rejection area. So what is your decision? Do you reject the null hypothesis? Yes, you reject. And therefore, we say a proper way of writing it is Z is equal to 3.2, the test statistics that is, equal to 3.2, which is greater than 1.6449, it falls in the rejection region. Therefore, we reject the null hypothesis at alpha equals to 0.05 and conclude that the new tires are better than the old tires. You see, class, what we do here, what we have decided here is we reject the null hypothesis. We reject it. We don't accept it. We reject it, and therefore we say the mean life, this is what we accept. The mean life of the new tires is better than the old tires. We agree with that statement because we already reject the null hypothesis. And it's very important. And it's very important that you must state that what is the level of significance. In this example, the level of significance is alpha equals to 0.05. Sometimes, class, even when the alpha is um, only a small difference, like alpha is 0.01, with the same calculation, you'll find that just a small difference of, between 0.05 and 0.01, small difference, it may be that instead of rejecting, it may be we accept. So it depends on the alpha. So that's why in your conclusion, it is important to write what is your alpha. Yeah. So I hope that clears. Who was it who turned on the
Me.
microphone? Mm-hmm.
If the null hypothesis is equal to the mean greater than 40,000, can switch please.
Come again. Sorry. How do you
The
say?
null, the null hypothesis is equal to the mean greater than 40,000.
Oh, you mean you write up here? Hang on, let me erase it a bit. You mean up here in the null hypothesis, you write it as mean, or this one is the one that you write like that, is it?
And the H1 is the mean equal to 40,000.
Or tidak? You should not be writing in that manner. Always write the null hypothesis as the original claim, and the alternative is the one that you say what is happening.
No. No.
Yeah. Is that clear? Noel? Noel. Okay, is it?
Right. Okay.
Okay.
The answer must be so long, man.
Sorry, Calvin?
The answer must write so long.
Which one is long?
The answer.
You mean the conclusion?
Yeah,
Is it long?
I don't know. And
Oh yeah.
It's not-
Do we need to write a sentence like that?
Yes, you have to. It is not long compared to all your other subject like essay subject. I mean theory subject, it's much more longer, isn't it? This one is short lah, guys. Not too long. Farah, do you think it's long?
Um, I think it's also lah 50-50.
You are the middle person now. It's not long. It's just that you're just making a simple conclusion. If you say it's long, yeah, perhaps for mathematics subject, but yeah, you have to write because this conclusion is about 2 marks, somewhat like that. Because first you make a declaration that you reject or you do not reject the null hypothesis, and then you write your conclusion. So it is important to write. Okay, Calvin?
okay.
Okay, yeah, have to write it though. So I hope that is clear. Any other question, class? No?
So
If
in
no,
the formula must be the sample.
yeah,
Must use this. Oh, okay.
yeah. Like this one, I mentioned about the n being more than 30, right? Remember in the note. Where's my pen now? You see the n is 64. Therefore, this one it should be s. Yeah. By right lah. Should be s because you see, if I go back to the slide showing the question, does it say anything about the standard deviation known or unknown? It's not, isn't it? So by right, um, well, you see, it does tell us the mean is this value, but no information about the standard deviation. We can assume that the standard deviation is unknown in such case. So because the standard deviation is unknown, I mean this is for the population basically, yeah. But therefore, if I go back to the slide which I explained to you just now, oh, the standard deviation is known, then we use it. I got mixed up, yeah. So by right, Going back to the question, because you see the question given to you in the exam or in the assignment, it won't tell you whether the standard deviation is known or not. So let me see. Yeah, it's not given. Yeah, it's not directly informed. So I will do check what kind of labeling you would use, especially using the sigma or the S, but I won't penalize you so much about that. What I'm concerned is you get the correct value of the test statistics.
The
Yeah.
standard deviation refers to which one of the sample or the population?
Um, we refer to the sample because you see here, um, eh, yeah, we refer to the population, sorry, because the standard deviation for the sample is not given. This is the sample one. This
So
value,
the
the sample standard deviation is not given.
although so we
We use
state that
the
it no
population.
no
Yeah.
yeah.
All right. Okay. Let's I hope it's clear already. But my suggestion is to focus on the value of the n. As long as it's more than 30, put s in your formula. Or some students, you know what they do? They don't write this. They don't write this formula. They simply write the value, because whatever you're taking of the sigma or you're taking on the s, it's the same value. Yeah. So some students, they did that. They didn't write the formula. They just write the answer. So that is still what is the focus is the answer. Yeah, the value that is the correct one. Okay, so I hope that is clear. We go on to the next part then, another example. So the reason why I want you to look at this question is because it's still on population mean. Yeah, and you can see here in this question, you have the word exceed. So I purposely have make it bold and bigger and red so that you can see that the mean income of families is exceeding 14,400. Yeah, this is the mean, it exceed. And we're using the alpha equals to 0.05. You see the word level of significance. So that's how you know this question is a hypothesis testing question. And then we have a sample of 60 families. And we have the mean is 14,524 and standard deviation is 763. Yeah. So here you can see that the standard deviation is given for the sample. This is the sample mean. This is the sample standard deviation. So what we do here is again list out all the given information. Yeah. So that's the value of the mean, the standard deviation, the n, the sample mean, and the mu is equivalent to the true mean incomes of the family. Is that clear, class, so far? So notice I'm using S here because the value of the sample is given. The value of the sample of the standard deviation is given to us. So from here, we state the null hypothesis is equal to 14,400. Remember the word exceed, yeah, where my pointer is now. We say the alternative hypothesis is the mean is greater than 14,400, which which is the mean income of families living within 2 miles of a proposed building site will exceed 14,400. So this is very important decision that, say you're a politician and you want to ensure that when you have a new building site, does it increase the income of the families within 2 miles from that building? Will it increase their income? Yeah. So when there is a claim like this with statistical values that we have, like the mean and standard deviation, of course, it's more credible, more reliable, isn't it? So when you present it to the public, they are more rest assured in that sense. So therefore, when we do the testing for this, at alpha equals to 0.05, we assume that there is a standard error of 0.05. Therefore, since it's greater than, it is a one tail. Greater than means it's a positive or the right tail. So that's why your Z alpha, you don't have to divide by 2, of which again we have 1.6449. So let me just draw the normal distribution. Now in exam, you will not, in exam or in your assignment, you do not need to draw it. Yeah, you do not need to draw the normal distribution. There's no marks allocated for drawing this diagram. But for me, I find it, I don't know, I'm used to drawing it so that I will not make a careless conclusion. So we know that this is the rejection region, just like the example just now. Yeah, so from here, our decision is therefore we will reject the null hypothesis if our Z is greater than 1.6449. Otherwise, we do not reject it. You see, always the decision is similar. Once you determine correctly what tail you're using, one tail or two tail, left or right, then you do the decision. Next thing is to do the test statistics. And when you calculate it, you'll get 1.259. Yeah, if you calculate it, you get 1.259, which is here. It is on that particular area. It is not to reject the null hypothesis. So that means the null hypothesis here is true. We do not reject it. And therefore, our conclusion is, since our Z is 1.259, which is less than 1.6449, we do not reject the null hypothesis at alpha equals to 0.05. Hence, or therefore, in conclusion, there is no evidence to suggest that the mean income of families living within the 2 miles exceed 14,400. Meaning it's the same. It doesn't give us any change, any exceed of the income of the families. Even though you have a new building site, it will not increase the income of the families. Is that clear, class?
Oh yeah.
Yeah. Yeah. So when you do the second example, do you realize it's much more easier to, to get the idea, the concept of it already? Okay.
Oh yeah.
Okay. So let's go on to the next example. Now this is another example. Check it out. We have a mean of 1.6. Let me change my laser pointer. And a sample of 50, that's your N. It gives a mean of 1.51 and a standard deviation of 0.3. Our S is known. The sample value of S is given. Again, alpha is 0.05, 5% level. You see, it doesn't write significant levels, just says level. As long as you see this, you know you have to solve the question using hypothesis testing. And we want to test that the population mean is less than 1.6. So that's the clue. So what kind of tests are we doing, class? One tail or two tail?
One.
Left or right?
Left.
Yes, because it's less than. So here we write all the information given. Yeah, the mean, the sample, standard deviation, the N, the sample mean. And we say mu is the population mean. The hypothesis, we say mu is equal to 1.6, but because we say it's less than 1.6, yeah, and therefore at alpha equals to 0.05, the critical value, notice here class, what happens? Because it's on a left tail, it will be negative. because you still refer to 0.05, it's still 1.6449. But notice that it is on the negative side. So it will be something like this. Sorry about my drawing, it's a bit, crooked one side, but it's on this side. And it will be negative 1.6449. You clear? So here we do the decision. We say we will reject the null hypothesis if the z is less than negative 1.6449. Otherwise, we do not reject it. And hence, do the test calculation. And you get negative 2.121. And when you draw it here, it is on this side, because negative 2.121 is there on the negative. It's much lesser or smaller than negative 1.6449. And our conclusion is therefore it is on the rejection region. What do? We reject. We reject the null hypothesis. We don't accept it. It's rejected. And we accept. Well, I don't normally use the word accept. We reject the null hypothesis at alpha equals to 0.05 and conclude that the population mean is less than 1.6. That means I agree with this statement. It is less than 1.6. So whatever is the alternative hypothesis, if you already reject the null hypothesis, you quote or you conclude using the alternative hypothesis. Is that clear, class?
Right.
Yeah.
Okay.
Okay, good. So I hope this helps you guys to understand about this. Yeah, is there another example? Yeah, there is another example. I would like, is this answer provided to you guys?
In the notes.
Sorry,
Is it in the notes?
is it available in your notes?
Don't,
I didn't get, I didn't get you, Noel.
do you have to check our notes for
Oh, okay,
answer?
okay. All right, doesn't matter then. That would be the next example, but I think I should give you guys a break now. So hang on, is that the answer already? So we'll do this later on after the 10 minutes break. We'll continue with example. Oh dear, what am I doing? Example 4, where is it? Too fast. Yeah, this is it, what we're going to do next. But before that, let me leave this page for you guys. We'll return at exactly 10 a.m. Okay, so have a 10 minutes break, everyone.
Okay.
Okay.
Okay, hello. Welcome back, everyone. Are you all here?
Yeah.
Okay. Let's continue with the next example. I should have finished it just now, but never mind. Maybe you did have time to reflect on the other question, and hopefully you can understand this better. Yeah. So this is about the lifetime of electrical light bulbs. So you see the word here, the word expected. Do know that the word expected is the same as mean. Yeah. So this is a mean value. 1,500 is the mean value. And a sample of 40, where from that sample, it has the sample mean of 1410 hours, and the standard deviation is 90. And we want to test the hypothesis that it has not changed. So you see, using alpha equals to 0.05, what tail do you use? One tail or two tail?
Two. Is it two?
Yes, exactly. It is two tail because the question tells us that we want to test that the claim has not changed. So therefore, if you check out, well, all this information, I bet you guys know already how to jot it down. What is the random variable? It's about the lifetime of electrical light bulbs. And therefore, the hypothesis is equal to 1,500. Therefore, no change means, has changed means mu is not equal to 1,500. And because this is the alternative hypothesis, therefore, our critical value is that our alpha we have to divide by 2. So at 0.05, divide by 2, the alpha, you get 0.025. And when you check from the table, 0.025 is equivalent to 1.96. And basically, class, this is how it looks like. Two tail. So we have one here on the negative side and one on the positive side. Yeah, this is 1.96, and here would be 1.96, negative 1.96. So this is the rejection area. So our decision is we will reject the null hypothesis if our z is less than negative 1.96, or if our z is greater than 1.96. Otherwise, we do not reject the null hypothesis. So when you do the test statistics, same formula, you get a negative 6.325. Yeah. So the calculation of it, I bet you guys are okay. Negative would be here. Negative 6, that is. Negative 6.325. So roughly it's there. And what do? We reject the null hypothesis because it is on the rejection region. So you reject this. What is your decision? The lifetime of the light bulb has changed. Yeah. So this is our conclusion. But very importantly, you must write this. State this and your decision to reject. And the conclusion is the second sentence. This is your conclusion. Hence, there is evidence to suggest that the mean lifetime of the electrical light bulbs has changed. Now, the words for the conclusion, it's up to you. As long as you can write similar meaning. Yeah, either you reject, when you reject the null hypothesis, then you take or you support the alternative. If you do not reject the null hypothesis, therefore you write the conclusion based on the null hypothesis. But in this example, we reject the null hypothesis. That's why our conclusion is in support to the alternative hypothesis conclusion. So I hope that is clear for everyone. Is it?
Miss, the one the Z can it be more than four?
Yeah. Oh, okay. Because I think you see, because it's negative 6.325. Yeah, I agree. That means you have been paying attention, because remember I did say when you talk about Z, you have the most is -4 and the most here is 4, right? For the Z. That is a good
Right.
question, Noel. The thing is, for our table, we only use until the value of -4 to 4, but in actuality, it is more than that. Uh, but it's just that the table that we're using is only to that limit. But actually, Z can go on and on and on. But of course, the value will be very, 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 very small. So for our case, because we only get until the accurateness to up to 4 decimal places, we only take from -4 to 4 only. Yeah, but of course, the value of the Z can go further than that. Yeah, but that is a good question now.
Okay.
Okay, you understand, yeah? So that's how we solve it. Any question, class?
So,
So far no.
Yeah, good, good. Calvin, how about you?
Okay. All
Okay.
still the same as everything we learned before one, I think.
Yeah, it's the same. That's why. Oh, why there's a Japanese person next to you? Is it Calvin? I hear like a Japanese.
Nah, never mind. My never mind.
Well, anyhow, what is it? Yeah, it's the same. That's why when we started doing estimation and we started doing confidence interval, you see, it was like an introduction to how hypothesis is calculated. Yeah, so yeah, it's related. Ever since we started doing normal distribution, we have been looking at Z and how Z is being used until this chapter. Yeah,
Yeah, as
in
long as we
fact,
know how to do the Z and then
mm, the hypo-
the graph
yes,
thing.
the hypothesis. Yeah, decide which one is the correct tail, two tail or one tail. And if you know
And then
that, yeah,
everything else just reading the question and then finding out which one to use on.
exactly. And not being careless. That's the only thing. So you see,
Okay.
yeah, so you see, it's doable. So it's just that you see students, what I've experienced lah, it's just that students, they're not exposed to it. It's new. Of course, when you're learning something new, it takes time to understand. And that is where you have to put your full effort to understand. And once you understand it, it becomes easy. Yeah, so I hope I have made it clear. But now we need to learn another method. Um, this is another one which also available in your notes. Should I go through this? Because I want, because you know about it already, right? So I just go through the question fast. 2 kilograms or more within the first month after joining the club. This is about losing weight. Yeah. So on average, they lose 2 kilograms or more. And to check the claim, and the sample is 36, average is 1.8, with a standard deviation is 0.5, and test the management claim. So in this example, the claim is to lose an average 2 kilograms or more. But in this case, they found they lost an average of 1.8 kilograms. Yeah. So what do you think it will be? One tail or two tail? So this is where you have to decide. And a lot of students, they get confused with the question. So do check the question carefully, because in this question, it is, you see, it's all stated, all the information. What is the random variable? And the hypothesis is this. Yeah. So comparing with the question, you see the claim, oops, too fast, is 2 kilograms or more. That's the claim. Okay. So you can see the hypothesis is that. But the alternative is basically it's less than that. So in this case, we have a one tail, and it's a left tail because it's looking at the alternative, it is less than. Yeah, so that's why we have a left tail. You can see it's negative 1.6449 based on 0.05 significant level. Now, oh yeah, this one, some students would write it simply as this. Without the greater than, they simply write like that. It is also accepted. Okay, so here then do the rest the same. Do your decision. Calculate your test statistics, which is negative 2.4, and that is definitely on the rejection area. And we reject the null hypothesis. And since we reject the null hypothesis, we say that the members did not lose weight on average of 2 kilograms or more within the first month of joining the club. Or you could also say there is evidence to suggest that the members, well, lose less than 2 kilograms on average within the first um, month of joining the club.
If they're answering and then the wording a bit wrong.
Then you lose 1 mark lah. I mean,
Okay.
if you have written the rejection, whether your conclusion here is no, your decision here is correct, but when you write your conclusion, it doesn't support what your decision is, then you will lose marks. So it must tally. Yeah.
Okay.
So some students, and they do this like rushing for the time during exam.
Yeah, because I really scared when I'm trying to write and then no time already.
Yeah,
Always think of-
that's what happens. Yeah, they incorrectly write the conclusion, and they lose marks lah in that sense. Be careful lah when always use this hypothesis as a guideline for you to write your conclusion. Because I bet once you have already do the test statistics, and then of course your conclusion, your decision is correct, but the writing the conclusion is where students tend to lose, to get it wrong. Yeah. Okay, so I hope that is clear, because the next one, yes, this is the one that I want to focus on now. This is you can see better, I get my laser pointer.
so many
This-
formula. It's
No.
the formula given.
Of course it's given, it's open book for you guys. You guys are very lucky, you have open book still. Yeah, I mean, students in the past, they don't have open book and it's maths paper, they cannot refer back to the notes, or even theory. Like sometimes the theory paper, facts, you can remember when you're learning, but during exam you forget. But because it's open book, you can check out and revive back what you've learned. So that's the benefit of during this pandemic, and you should score. Yeah, try your best to score. Anyhow, class, this is the same. Yeah, it's just about population proportion. You see, hypothesis testing about a population proportion. And if you look at the null and alternative hypothesis, it's the same. See, the first one, two tail because changes. Second one, more than left tail. Well, it is less than left tail. And then the third one is more than, it is right tail. The test statistics, you can either use this formula or this formula. Either one, it's correct. Yeah, or you could use this formula. But the norm is to use this one, not the first one. Most marking scheme is using the first one. So focus on this one. You can use this, you can use it. It's the same, but I prefer this one. It's much more clear cut for me. I don't know. I'm used to this one. And look at it, the critical value and rejection region the same. If it's the first one, two tail, see, divide by 2. One tail left, negative. One tail right, positive. See, no change. It's just that when you see it first glance, wow, so many, you say. But actually, once you really sit down and look at it, it's only one thing you need to remember, the formula, this one only. And You guys don't have to memorize it. It's given. And in fact, if it's not during the pandemic, the formula is included in the formula sheet. Yeah. So let's try out. Same thing, the two tail and the one tail, same concept, just like what I've explained. However, you do need to take note that now you see the pi zero, it's the population proportion. It's a predetermined constant. Previously, what we used in the previous example, it was the mean. Remember, for proportion, a population mean. Now we're doing population proportion, it's the pi zero. The PS is the notation we use for the sample proportion, and the population proportion pi is used instead of the sample proportion because the population proportion is known. So these are the only difference as compared to what we've done in the previous example. So they are the same. So let's look at an example here. And you notice or not, one thing you should notice here is that now the question doesn't give you the value of the mean or the value of the standard deviation. Immediately you know this is population proportion. And you know you have to do hypothesis because it is 5% level of significance. You know it's a hypothesis question. And therefore, it's a population proportion. No value of mean, no value of standard deviation. If the value of the mean and standard deviation is given, and you know it's a 5% or whatever level of significance is given to you, you know it's a population mean question. But this one is a population proportion. And we want to check or to test the hypothesis that the proportion of school students owning a calculator is more than 80%. So what tail? One tail, two tail, left or right?
Right.
Yes, one tail. It's a right tail. Because the word, the claim, we want to test more than 80%. Yeah. So here we have n equals to 200. That was given in the question. And from the 200 randomly chosen school student, 163 of them own a calculator. So from here we know our x is 163, of which our pi, the population proportion, is 80%, equivalent to 0.8. And for the P0, or the PS was it? Now I got confused. Is x over n. It's 163 divided by 200, and you get 0.815. Okay, so here our random variable is the pi, which is the true proportion of students owning a calculator. The claim is it's more than 80%, but we don't know whether the claim is true or not. So that's why we do a hypothesis testing. With the null hypothesis, we say it is 80%, but the claim is it's more than 80%. Proportion of school students owning a calculator is more than 80%. This is what it means. So therefore, as Noel had mentioned, it's a it's a one tail. It's the right tail. Yeah. So we have a positive value, 0.05. Again, same thing value. I should have changed the percentage. Yeah, it would be more interesting. So it's 1.6449 again. And just to draw, it's the same. You notice or not? It's the same as what we did. It's only that the formula now is different, especially the test statistics. So same thing, this is our rejection. This is 1.6449. And our decision, we will reject if it's more than 1.6449. Otherwise, we do not reject. And this is the test statistics. Put it into the formula. Put all the values that we have listed here. Put it into the formula and you get 0.53. Where is 0.53? 0.53 is somewhere here. What is your decision? Do you reject or do not reject?
Do not.
Yeah,
Thank you.
you do not reject. I think, Noel, you tried to say something but cannot hear you. But anyhow, it is we do not reject because it falls on the acceptance region. We do not reject the null hypothesis. That means we quote this is true. And therefore, you state it is less than 1.6449. We do not reject the null hypothesis at alpha equals to 0.05 and conclude there is not sufficient evidence. You see this word, not sufficient evidence, to suggest that the proportion of school students owning a calculator is more than 80%. So remember in the first few slides that when we started chapter 6 on hypothesis testing, I did show one slide stating there that you would use this word, not sufficient evidence, because we basically do not reject the null hypothesis. We agree with the null hypothesis. And we say no evidence can claim that students owning a calculator is more than 80%. So this is how, decision makers, when they do a survey, if you recall that now, instead of the people coming out to the houses and get a banqian, they call it banqian survey. Last time, previously, they come to your house and then knock on your door and then ask for information, right? Now we do it online. Like every household need to fill up the banqian, the survey. So when that happens, what they collect all that information and they do this kind of hypothesis testing. And from the data they collected, they would be able to decide maybe it could be about salary or the income of the household there. They would be able to identify which area has, this area, this kampong, the income of the household, is it below average or is it above average? And perhaps, hopefully, if we have a good politician involved in that area, they would be able to observe which area that needs more help. And therefore, from that statistical survey done, proper help can be given, to the people who needs more. Yeah. So I hope you see how important this hypothesis testing is. Do you?
Alright.
Okay.
Not sure. Okay lah.
Yeah. Maybe now because you guys are still studying, you won't be able to grasp how important it is. But if, let's say, in the future when you go and you join a company and it deals with something like this, you'll see how relevant it is, to your work and also to the society. Yeah. So this is another example, and this is about election, class. And you can see election candidate, he claims, well, this is based on belief, that 60% of the voters will support him. So they took a sample of 2,500 voters, and what they have collected is that 1,400 supports him. Now remember, it's not only 2,500 voters, there are more than that. Yes or not? Yeah, definitely more. But they just took a sample of 2,500 to test whether his claim is true or not. And what we do is we want to test the claim at 0.10 level of significance. And here we have all that information. You see the N, from that 2,500, 1,400 support him. His claim is 60%, and therefore we can get our P 1,400 divided by 2,500, you get 0.56. And from here, our random variable voters, the pi is voters supporting an election candidate, and therefore it's either the hypothesis, null hypothesis, it's equal to the claim, or it could not be equal to 0.6 change lah, basically, or difference, from the value that was claimed. So this is not equal to 0.6. Yeah, so this definitely will be a two-tailed. Yeah, and from there, alpha is 0.10, and therefore the alpha you divide by 2, notice that we have plus minus. So that means because it's a two-tail, it will be something like this, just like what we have discussed in the previous topic. I mean, same topic, but different area. So this is the negative 1.6, and here would be positive 1.6. And the shaded region is the one that we reject. So same thing, yeah, class. Our decision to reject the value less than negative 1.6 or the value more than 1.6. Otherwise, we do not reject. Put it into the test statistics, you get negative 4.082. And that would be here. We reject. We do not, we reject the null hypothesis. And when we reject it, therefore, the alternative hypothesis is, therefore taken into consideration. We reject the null hypothesis at alpha equals to 0.10. And our conclusion is there is not sufficient evidence to support an election candidate claims that 60% of the voters support him.
Miss,
Hmm?
so if the word is say more than 60%, then we use the right tail.
Yes, if it's more than 60%, then you use right tail. Yeah,
Oh,
okay. I hope that is clear. Anybody has any question? No?
No.
Okay. So this is another example. Yeah, example 8. This is where a coin is tossed. Very short, simple question. And you can see there is no mean, no standard deviation. You know this is a population proportion. And the coin is tossed 100 times. That is your n. And 38 heads are obtained. Is there evidence at the 2% level? Yay, this is where our alpha is equal to 0.02, that the coin is biased in favor of tails. So, class, what is your pi? We know our n is 100 and our x is 38, right? Therefore, our p, ps or p0, I think it's ps, yeah, is 38 over 100. What is our pi?
is it
Pi meaning like the number pi 3.14.
No,
Oh,
it's the population proportion. What is the, because in this question it's about the coin. Now think about it. A coin, here it says it's biased in favor of tails. But look at the first sentence. It's about the heads from 100 times you throw. So we have derived that. I've already given you this. That means your proportion of getting a head is 38 over 100. But what is your proportion, your pi? That means the first initial proportion. concerning a coin. When we're dealing with a coin, there's only two possibilities, yes or no? Head
Oh, yeah.
or tail. So when it's proportion of heads, notice here the first sentence, it's about head. So what is your pi?
0.3
No.
0.5.
Exactly.
Oh,
0.5, because by right, when you throw a coin, it should not be biased, isn't it? It should be fair. It should be 0.5. So that means your pi, this is your null hypothesis, should be equal to 0.5. Your pi is concerning with the heads. I mean, when you throw a coin, the probability of getting a head is 0.5. So if your null hypothesis is 0.5, what is your alternative hypothesis? 0.5. What is the symbol we have here? Because once you determine your hypothesis, then you know whether it's a one tail or a two tail.
not equal.
I no, it's not equal. Of course, that would be a good suggestion also, not equal. But think of it. Think of this last sentence you see here. It stated a coin
More
is
than
biased. Huh?
more than one tail.
Less than.
Less than or more than?
Because this one is for the heads. So
Yes, correct, Noel. So it will be,
less than.
yeah, exactly. Because the pi is focusing on the head. And look at this sentence, it's biased in favor of tails. So the tails value is more than 0.5 because it's in favor of tails. So therefore your alternative is the pi is less than 0.5 because your tail is winning. So your head will be less than 0.5. So is it one tail or two tail? One tail. Left or right?
Left.
Left. Yeah, so I see Noel understand. Calvin, I bet you do. Farah, how about you? Do you understand?
Yeah.
Okay, so here, I hope everyone understood. So you see the solution, yeah? You can see the pi 0 is given to you as 0.5, and therefore pi be the proportion of heads obtained in the population. So it would be less than, because the coin is biased and in favor of tails. That's why the pi is less than 0.5. So here at alpha equals to 0.02, critical value is, well, left. So therefore we get a negative. And when you draw the normal distribution, it will be negative 2.05. And it will be here, right? That would be your rejection. The decision is if you get less than negative 2.0537, we would not we reject the null hypothesis. Otherwise, we do not reject. So when you put into the formula and you calculate, you get negative 2.4. What is your decision? It's here. So what is your decision? To reject.
Reject.
Exactly. And conclude, because you reject the null hypothesis, you conclude that there is evidence. Check out the words. There is evidence to support that the coin is biased in favor of the tails. I hope you understand how it works. So some question can be as tricky as this one. I think this example is a bit, you need to spend time and think about it more. Yeah. Yeah. Okay, so I have to be very careful, especially
The
This one
decision.
easy,
Mhm.
very easy to make mistake.
Sorry, Calvin?
Very easy to make mistake. That's all.
Exactly. Yeah, that's what I wanted to point out. The
If the formula,
words.
if our formula okay, and then we get the number wrong, really,
Yeah.
really
Yeah.
also minus mark on it.
Because when your hypothesis is wrong, definitely, of course, the Z definitely always correct lah. But when your hypothesis is wrong, it will affect your answer here.
So
But
hypothesis wrong, and then everything zero.
no. That's what I want to raise up here also, so that you guys will have confidence in answering this. So don't worry. Even though, let's say you read the question and the hypothesis you have written wrongly, I would still, give marks to the rest of the answer based on your hypothesis, on your own hypothesis. Even though your hypothesis is wrong, I will still, because you already lose marks in the hypothesis, and then if there's any other careless mistake, you lose marks also. But the rest of the working is based on your incorrect hypothesis. And that is one good thing about TA. You see, we ensure we check for any double, no double penalty lah. We don't deduct marks on marks that has already been deducted in the earlier step, because this working is it's like, how do you say, it's a continuation from the earlier part. So it's not fair. You already deduct up here in the hypothesis, and then you deduct when your conclusion is based on your own hypothesis, isn't it? So don't worry about that.
Oh, don't have
Okay,
double penalty.
come again.
Don't have the double penalty.
Exactly. Yeah, so that's why you will only not get marks if you answer nothing. If you answer something, of course, you answer with sense, of course. I mean, you answer with knowledge. It's just that maybe perhaps earlier part you make careless mistake, you get marks. You still get marks. The only reason why students don't get marks is when they submit zero. Or maybe they wrote something but it doesn't relevant, it's not relevant at all. Then of course no marks. But basically, when I do my marking, I do give marks for even wrong answer. So that's why class, it takes me time to mark, because when students give me wrong answer, I would, really analyze their answer again. What caused them to get this answer? So I have to really check students' work one by one, and that takes a lot of time. But I want to be fair, yeah, when marking papers. So you see, sometimes when I mark them, I get confused myself. So again, that's why it's important that I share the solution with the students. Student can pinpoint to me which area that which area that I make mistake in my marking, and therefore can correct it lah. Yeah. So yeah, we apply the same thing for the final exam as well as your assignment and test. So don't lose confidence in answering this. But still, especially diploma students, they do not have enough, revision, and they lack confidence in answering this kind of question, and they just, leave it blank. And when you do that, how could I give marks? Exactly. Do you know my meaning? Yeah. Like this, you can, some students, I've seen students, yeah, they just answer me this, but they get marks. They get 2, 3 marks for this. So yeah. Right. Is that clear about no double penalty concerning question like this?
Oh, yeah.
Yeah. Yeah. The business students for diploma, they don't have to do this. Only for the diploma. But the business students for degree, they have this question in their final exam, same as you guys. And the diploma for the computing students, they also have this question in the final exam. So I see a lot in the diploma students, that is, the diploma students, they don't dare to answer this, they leave it blank. So sayang lah, I think it's a they didn't know the topic well enough to answer it. But it's actually easy. What do you think? Do you think it's easy?
are not so easy. I still need more practice. Still need to practice before saying it.
Exactly. That's the keyword, Calvin. I like that when you say practice. Practice is important. It's like just like driving, isn't it? When you first started driving, for me lah, especially, I don't like driving. I like my husband to send me where I want to go. And like when all of us started driving, we have to keep on practicing. Now you drive even with looking at handphone at the same time, you can still drive, isn't it? But that is dangerous, everyone. Okay, so I hope that is clear. This is another question. Yeah. So is this the last one? I'm not so sure. This one is sells computers, parts by mail, and the claim. You see this keyword? 90%, at least 90% are mailed within 72 hours after they receive. Yeah. And then the sample is 150 orders, and 129 are mailed within 72 hours. So you see, this would be your P. Yeah. Your N is 150 and 129 are meeting up to the requirement that they are mailed. Do you think the company's claim is true? And we use a 2.5 significance level. So what do you think? It says at least 90%. So your pi should be somewhere here. That would be at least 90%. So 0.9 is your pi for the null hypothesis. What is your alternative hypothesis? I hope I'm right. I'm just like thinking based on the question. At least 90%. So 0.9, more than or less than?
More than.
Exactly. Yeah. Did I give the answer? I did give the answer. So since we have discussed that, let me just share with you guys. Salah kita. Hang on.
The assumed one. The assumed
Let
is
me
more
read.
than. The assumed one is at least more than. At least 90% or more than.
Yeah, I assume it's more than my mistake. Oh dear. A company claims that at least 90%. That means this is where I got it confused. The company claims that at least 90%. That means at most 90%.
No. At most 90%. No, it says at least 90% are male.
90% are male.
At least is more than.
Yeah,
Right.
but then you see here the hypothesis.
Yeah, it says at least 90%.
Yeah, that is correct. So always, okay. Oh, but I was thinking that it should be more than in this alternative. Based on the sentence, this is correct. Yeah, my confusion. I get confused myself. Yeah. So because we already stated the null hypothesis is greater than, so the alternative must be the opposite of it. Always the opposite of the claim. Yeah. So this is the null hypothesis, the pi, the population proportion is more than or equal to 90% or 0.9, and the alternative is less than 0.9. So therefore, at alpha equals to 0.025, critical value, because we're dealing with less than, it would be a left tail. Let me draw the diagram. Oh yeah, just to remind everyone, again, this diagram is not awarded any marks. No marks for this one, yeah. So I'm just drawing it just to ensure that you can see the area rejected or not rejected. And therefore, once we have decided it's less than negative 1.96, we reject. Otherwise, we do not reject. And when you do the test statistics, you get somewhat here, negative 1.6 0.33, which is on the non-rejection area. So therefore, we do not reject the null hypothesis at alpha equals to 0.025 and conclude there is evidence to support that the company's claim the orders are mailed within 72 hours of receiving it. Yeah? Is that clear, class?
Okay.
Any question from anyone? No?
So far.
So far, no. So I hope that's clear. Tomorrow's tutorial will be focusing on tutorial 8. And I would like to do all the even numbers, question 2, 4, 6, 8, and 10. Tutorial 8, question 2, 4, 6, 8, and 10. And I have extra example here. So this is one example I want you to do as well. Is it okay? Yeah, so this is one extra example. I will send it in our WhatsApp group. In fact, I have two examples here. So do this question and another question, 2 questions, and another 5 questions from the tutorial 8. So I hope you guys try and do it. Spend a bit of time on it, and we'll discuss it tomorrow because it's almost 11 and I'm about to end the session. Unless you guys have any other question, that is.
Or the assignment, what chapter will it cover?
The assignment? What assignment?
Oh.
You mean for your assessment?
No. Math don't have assignment anymore.
Oh, you have. You have an assignment which is on week
11.
Is it? Very hard for me to remember now because I have 5 subjects gone, so I have to refer it back. I did tell you guys, yeah. Week 11, I was saying it is 7 question altogether for your assignment, but of course, assignment there would be a few days for you to complete it, and it will cover chapter 2, 3, 4, 5. Not chapter 6 though. Yeah. Chapter 2, 3, 4, and 5 only. Ayo, so easy lah your assignment. That's all. But your tutorial for tomorrow, what did I say just now? Forgetful.
Tutorial 8.
Yes, thank you, Farah. Tutorial 8, question 2, 4, 6, 8, and 10. And of course, I'm giving another 2 questions later on, using our WhatsApp. So try and do it, class. I'm not forcing you guys to do it. Well, I hope you do it. But I hope you do it. But if, let's say, you're unable to complete it, don't worry. I'll still discuss it with you guys. Okay, so I'll see you guys tomorrow. I think that's all. If there is no other question, then thank you.
Okay,
Thank you,
Miss.
Miss.
Okay, bye-bye.
Okay, Miss. Bye-bye.